Okay, today we're going to learn about a perpendicular bisector. So here's what I want you to do. Take your ruler. You should have gotten your sheet of copy paper and cut it in half. If you haven't done that, hit pause and do that. Grab your ruler, and I want you to draw a segment. Any kind of segment you want. Okay? Call this point A and call this point B. Now, also, you probably want to do this with a marker. If you have a pencil, you might either want to just make sure your pencil's dark or get a marker or a pen because you're going to need to be able to see this through. So what you're going to do now is take this segment and I want you to fold it in half, which means you're going to take point A and fold it on top of point B, like this. And you can kind of see through mine because I've got a black marker, but if you need to, hold it up to the light so you can see. But can you kind of see where my two lines don't match up exactly? You want to match them up so that A is sitting exactly on top of B. Okay, so if you can kind of see through, my segments are right on top of each other. I've got A sitting exactly on top of B, and then you're just going to crease this all the way through. Okay, so when you open it up, you have a crease going straight through your segment. So since we folded it in half, we're going to put a point right here. That point is the midpoint because we folded it in half, so we know that's the middle. So to show it's the midpoint, we're going to put a tick mark on each side, and we're going to call that point M. Okay? Now, take your ruler, and since we fold it in half, y'all see this angle right here from the crease to this segment? That angle is a right angle. So take your ruler, and I want you to trace the crease you just made. And then put a right angle there to show that it's a right angle. Okay? This segment is called a perpendicular bisector. Perpendicular bisector. Perpendicular, if you remember from Unit 2, the word perpendicular means you make a right angle, and the word bisect means you cut in half. So this segment has made a right angle, and it's cut segment AB in half because AM is congruent to MB. Okay, now, what we're going to do in this unit is learn something that's true about a perpendicular bisector. So I want you to take point C, and I want you to put point C anywhere you want to on this perpendicular bisector. It does not matter where. I'm going to put mine right here. You can put yours anywhere you want to as long as it's on this line. So we're going to call that point C. Now I want you to use your ruler. If you don't use your ruler, it will mess it up. Draw a segment between A and C. Draw a segment between A and C. And then draw a segment between C and B. Okay? Now, pick up your paper. I want you to fold it in half, and I want you to look at the segments you just drew. When you fold it in half, do you see how these two segments sit right on top of each other? That's because they're the same length. AC is congruent to CB, and if you want to, take your ruler, and you can measure AC. So this one is about 6.5 centimeters, and then measure CB. And it's also 6.5 centimeters. So you can measure it and see that they're the same as well. So I want you to put 2 tick marks on that segment and 2 tick marks on that segment. So point C is the same distance from A as it is from B. And what made it be the same distance is that it's on this perpendicular bisector. We're going to try that one more time. Now I want you to take point D. And I want you to put point D anywhere you want to on this perpendicular bisector. I'm going to put mine up here. Okay, do the same thing. Draw a segment between A and D, and between D and B. Okay, and now if you pick it up and you fold your paper on that crease, you're going to see that segment you just made, that it's congruent to the other. They sit right on top of each other. And again, you can check it by measuring. But these two segments are the same. So what we figured out by doing this is that if I have a segment, remember we started with segment AB. If I have a segment and I make the perpendicular bisector, then any point on this perpendicular bisector, I could pick this point or this point or this point, any point on the perpendicular bisector will be the same distance to each endpoint. So D is the same distance from A as it is from B. C is the same distance from A as it is from B. We call that equidistant. When things are the same distance, we call it equidistant. So here's what I want you to write. Any point on a perpendicular bisector is equidistant to the endpoints. I'm going to run out of room. To the endpoints of the segment. Any point on a perpendicular bisector is equidistant to the endpoints of the segment. So in this unit, we're going to learn about 4 different types of triangle centers, or points of concurrency, and we'll talk about that later. But this is one of the types of segments that we're going to use in this unit. And you need to know that if I have a point on a perpendicular bisector, it's the same distance to the endpoints of the segment.